Good morning and welcome to our session. Let's start with a quick poll. How many here believe that securing your cloud applications is something you must do to gain regulatory compliance and certification? Good amount, good. How many of you believe that you must secure your cloud applications to protect your customers' personally identifiable information and your own intellectual property and assets? Okay, and how many of you believe that security should be the #1 concern in your organization? And we certainly feel like that in AWS. Security is our #1 concern. And also with ECS, every feature we develop, we have that tenet in mind, and we go through rigorous testing to ensure that is the case. My name is Spiros. I'm a product manager for ECS and Fargate, and I'm joined today with Yumeng, and we're going to go through a few of the existing and new features that we have on ECS and Fargate. So imagine a situation where an employee lives in a company, but for some reason, some of their credentials don't get purged from all the systems. Some of the largest breaches have happened through compromised credentials like that. And although AWS follows a shared responsibility security model, we're responsible for security of the cloud, meaning we secure the infrastructure where your applications run on. You're responsible for security in the cloud, meaning safeguarding the applications and your customers' data. So it's always important to know what your applications are doing, how they're behaving, because you have an amount of resources that you provision and throttle limits that you must meet. So you want to make sure that those resources do not fall prey to unauthorized usage. And compliance is very important. In fact, it's table stakes for a lot of industries. And that is something you must always strive to do in improving your security posture. But more importantly than that, it's also building trust. Building trust with your own customers, because they give their personal information to you to safeguard and curate, but also with your supply chain partners, because they also federate their interfaces with you and provide you with access to their intellectual property. So it is pretty important to build those trusting working relationships. Today, we'll take a look at the ECS security model and some of our enhanced security features we have developed. Plus, we're going to spend a good chunk of time on a new announcement we had this week of introducing guard duty runtime monitoring with ECS and Fargate. And we're going to show you a demo of the ECS operator experience. If you happen to be in the security session back on Tuesday, we went through the guard duty experience. And what you should bear in mind is that we designed this feature thinking that there could potentially be two different people that take advantage of this feature. A security administrator from the security team and an ECS platform operator from the infrastructure team. Containers, by definition, build inherent security by isolating resources and separating it from each other. ECS deploys in two different modes on different compute. There's the managed EC2 case, where this kind of separation happens at the instance level. And there's also the serverless mode, AWS Fargate, where that separation happens at the task level. And we'll show you a few features we did on EC2 to actually help resemble the Fargate experience and isolate the resources down to the task level as well. So when looking at the different deployment models, when you launch ECS on EC2, there are 3 trust boundaries that you must protect. There's the operating system and kernel to avoid a bad image from getting loaded. There's the instance itself, so you can safeguard against compromised credentials trying to get access to the resources, as well as protect any malicious traffic or messaging coming in. And there's also the application level. This is where your container runs with your application. So any kind of malware or software vulnerability that can be exploited, that can actually get access not only to the task resources, but also potentially to the instance resources, and then propagate that across other tasks. In Fargate, we greatly reduced the potential attack footprint, because the only place that someone can attack is the task. And because tasks are isolated from each other, there is no chance someone can go beyond that level and propagate this across many other tasks. So now let's take a look at how we create additional security features at every step of the ECS stack. So at the very bottom, we have the operating system and the kernel. We have the container runtime, like Docker or Containerd. And we have the ECS agent, which communicates to the ECS service so you can launch your containers in your clusters. So aside of the compute separation and the infrastructure patching, you can also define security groups. You can define network access control lists, so you can decide what traffic is allowed or disallowed at the subnet level. And you can also have IAM role for container instances. And with that, you can instruct what type of API calls the ECS agent or container runtime makes to your kernel. You can also leverage AWS Private Link. This is a way to set up communication between ECS and the VPC so the traffic doesn't go through the public internet. Moving one level up, the task is a collection of containers where you run your applications. It's an instantiation of your task definition file where you actually put all the configuration parameters for how you want your containers to run. So this is the point where you can define IAM role for tasks when you launch on EC2, because that helps you separate and isolate your user credentials down to the task level, making the EC2 experience look more like Fargate. It is also where you can do dedicated ENI for tasks. In a similar vein, you now take that isolation for network down to the task level and resemble the Fargate experience. And this is also where you set task execution role, where you can create the type of permissions that the task requires to execute, whether that means allowing them to create log groups, allowing to download container images, and so on. And then you have container. That's where your application runs. And this is a place where you can set container secrets, like API keys or user credentials or certificates. You can also adjust Linux kernel capabilities, either taking away some that your container doesn't need or add and enhance with AppArmor profiles, for example. And you have the option of running your container in privileged mode, although that gives you root access. So unless it's absolutely necessary, we encourage you to disable that. And ECS gives you a chance to do that. You also define user limits, both soft and hard, to protect against runaway application consuming a lot more than what they need to run, as well as image scanning and image pruning. If you use ECR, it already scans your images and makes sure that there are no software vulnerabilities. And ECS makes sure that the version that we get is the latest with all the updates and security patches. And at the very top, you have the application. So this is where your core business logic runs. When you run on Fargate, you also can add ancillary functions that run inside the same task as your application itself, things like logging or routing or monitoring. So some additional features we have here is implementing transport layer security for service-to-service communication, tag-based access control, so you can allow which actors can actually take actions and interact with your applications, as well as configuring all your parameters for your observability functions, things like log routing and metrics and debugging, tracing, and so on. So what we announced this week was the introduction of guard duty runtime monitoring support for Amazon ECS and Fargate. If you're not familiar with guard duty is AWS's intelligent threat detection service. ECS has been using guard duty for a long time, and that was to get things like VPC flow logs, DNS query logs, CloudTrail management events. But this is the first time we're actually using it for runtime threat detection. And in fact, it's the first time ever that we're doing it on a serverless setting with AWS Fargate. Earlier this year, we announced runtime threat detection with guard duty on ECS, which is the managed Kubernetes service that AWS provides. This week, along with this announcement, we also announced a preview on EC2 standalone as well. So between EKS, ECS, Fargate, and EC2, now you can enable runtime threat detection on any workload that your organization may demand. So how does that work? Well, every time that a new resource gets spun in ECS, we collect the telemetry around application behavior and send it over to the guard duty service, which applies machine learning, anomaly detection, and threat intelligence through their database to generate more than 30 different security findings specific to runtime threats. And at that point, you can look at those findings either natively on the guard duty console, or you can forward them on downstream to other services like Security Hub or Amazon Detective, or even set up an event hub to send them over to an APN partner that can actually aggregate and process further and perhaps provide remediation and response actions. Taking a closer look at how that's done. We have a lightweight guard duty runtime monitoring agent that we onboard on every EC2 resource. When you launch ECS on EC2, you can do this the same way you would do it on normal EC2. You can use the AWS Systems Manager to onboard it onto the EC2 instance. And at that point, we can monitor operating system and kernel information using eBPF probes, as well as all the application behavior running on all your containers, on all your tasks inside that instance. And another way to onboard that is through an RPM package that's on an S3 bucket. So you could always have the option to also bake that into your own AMI. The other thing you would need to do is set up a VPC endpoint so that telemetry can flow over to the guard duty service, where all that telemetry is used to calculate the security findings and be sent downstream. That way, that kind of sensitive information does not go through the public internet. On Fargate, we went even further. So here, the guard duty runtime monitoring agent is stored in ECR on a private repo. So if you already used the Amazon ECS managed execution role policy, there's nothing you need to do. Fargate will auto-inject the agent for you. If you don't, then you just have to ensure that the task execution role that your Fargate tasks have permission to download the image. And then, for every new task, either standalone or part of a service, Fargate will pull and auto-inject this agent in the task for you. That's it. There's no task definitions to change. There are no images to maintain, no upgrades to worry about. Every security patch and every upgrade, you're guaranteed that every new task will pull the latest image. And the added advantage with Fargate is guard duty will automatically set up the VPC endpoint for you. So the ultimate experience here is that your security administrator can enable this feature, and all of this can happen without the ECS operator lifting a finger. And this is kind of important to note, because in doing that kind of separation of responsibilities between the security administrator and the ECS operator, sometimes we find that, especially on the platform side, infrastructure operators are a little weary of someone else in one click going and saying, I want to run this on all your clusters in this account. So we also created some additional capabilities for the ECS operator to be able to work through this feature as well. And this is the type of thing that we're going to demo right now.
Thanks, Spiros. So in today's demo, I'll be demonstrating 2 different scenarios to walk through how do I enable my ECS workloads with this new GuardDuty ECS runtime monitoring feature on both Fargate and the ECS EC2 launch type. And this is from the ECS operator, ASAP application owner perspective. So in the first demo, I'll be walking through the steps to showcase how do I opt in a specific ECS cluster with my Fargate workloads into this new feature. As Spiros mentioned, we actually, as part of this feature, we support different enablement mechanism to cater for different ways of managing workloads from different personas within your organization. So for the security administrator, we provide a centralized place where you can just enable this ECS runtime monitoring feature with the GuardDuty agent auto deployment at the same place. So which means with 1 or 2 button clicks, you can have this feature enabled and have the GuardDuty agent deployed for all your Fargate workloads for all the managed accounts. However, this shouldn't happen until the ECS operators actually do the fully testing with your Fargate workloads, so that you can make sure that the whole integration is actually safe for your production workloads. And this first demo is actually I was just walking through steps and to demonstrate how do we achieve this. And for the second one, I will also touch base on how do I enable this feature on ECS EC2 cases. So at the moment, there is a customer experience difference on Fargate and ECS on EC2. So on Fargate, we're actually supporting a fully managed, automated, and seamless experience, which means you have one-click experience that we set up everything on behalf of you. And for ECS EC2, currently there's a couple more steps will be involved to set up network, or create the VPC endpoint, or install the GuardDuty agent. So next, let's see the feature in action. So during the today demo, I was using the AWS Management Console. And before we opt in our ECS cluster, the first thing we need to check is we have to make sure that the Amazon ECS runtime monitoring account setting is turned on. So if you come to the ECS console on the left side, you can see there's account setting option. And once you select it, it will redirect you to the page, which is shown on my screen. And if you scroll down, you can see there's Amazon ECS runtime monitoring account setting, and currently is already turned on. So this account setting is actually fully managed by GuardDuty, which means you cannot really update it through any ECS supported API. So when your security administrator in your company enable the runtime monitoring configuration on the GuardDuty side, it will be automatically turned on. So once we make sure to verify the account settings are turned on, we can now jump to the cluster page and try to opt in this cluster. So the cluster opt-in process is actually done through adding a predefined tags into your existing cluster, all created with your new clusters. So to add a tags to your existing cluster, we can come to the cluster page, and if you see there's up top section, there's update cluster button. And if you click it, you can see it will redirect to a page which you can update a subset of cluster configuration. And if you scroll down to the bottom, you can see there's a text section. So to opt in this specific cluster, you won't need to add a predefined tags whose key is guard duty managed and the value is true in order to opt in this cluster. So we also support the opposite, which means if you already have auto deployment enabled for all your account, you actually also be able to opt out a specific cluster within your account from this feature. So in order to do this, you just need to flip this value from true to false, and you will also be able to opt out your cluster from auto deployment. And when you test your feature, this integration, we highly recommend that you also enable the container insights, which if you see on this console, you can see there's, in the monitor section, there's a button you can toggle which help you to enable the container insights for your cluster. So container insights is a feature that we support that can help you to collect, aggregate, and analyze the metrics coming from, and logs coming from your container runtime and underlying infrastructure. So it help you to collect the resource utilization that consumed by your resource, task, cluster, service, and so that since, as Spiros mentioned, when we deploy the guard duty agent for your task, it was injected as a setup container within your Fargate task. So this means it will actually consume additional resources with your task. So enable this feature will help you understand what actually the resource usage, such as CPU, memory, consumed by this new guard duty container. So you can decide whether you need to adjust your task size accordingly. So once we have the configuration set up, we can click the update button to update our cluster. So when you opt in this cluster, it won't automatically directly apply to your running workloads, which means we won't actually go to replace and stop your already running workloads. You have to do a manual refresh. This means if your task is actually managed by service, you will need to trigger a new deployment. And if you have a new standalone tasks, you will have to create the new tasks. So once you have your cluster opt-in, and it will show up on your guard duty dashboard. So if you come to the guard duty console, you can see under your ECS cluster coverage dashboard, you can see my testing cluster already showed up here. It gives you all your information such as the coverage status and then how many instance nodes are covered in this dashboard. So now let's try to create some new tasks and to see what my task will look like after I enable this new feature. So as Spiros mentioned before, so the only changes that may need in your task, it totally depends on where your container image gets stored. So since the guard duty container image is stored in the ECR repository, that you may need to add an execution R in your task definition, which also have the required ECR permission so that the Fargate is able to pull down the guard duty image from the ECR repo. So if you already have the AWS managed ECS task execution policy used for your execution role, there's zero action required on your side. So this is the only changes we need in your task definition. And if, as I mentioned, if you already have your image stored in CR, you already have the ECR permission, there's no changes required. So now, since I have already updated my task definition, I can go create some new tasks. So if I click this Run New Task button, for the launch type, I will choose Fargate. And for the platform version, since this new feature, we only support platform version about 1.1.0, so you can choose either latest or 1.1.0 platform version. And since I'm going to create a new standalone task, I'll choose a task and also select the task definition I just created. And one thing I want to mention is, since the Fargate needs to be able to talk to ECR service to pull down the guard duty image, if your Fargate task is actually launched in the public subnet, you will need to have a public IP assigned to your Fargate task. And if your Fargate task actually living in the private subnet, there's two ways to achieve this. The first one is attach a network net gateway interface to your private subnet. And the second one is actually what we recommend is to create a ECR VPC endpoint so that your Fargate can talk to the ECR service. So once you have this networking set up, we can go create some new tasks. You can see on the bottom, this is my new task, and now it's in the provisioning status. So if we click the task, we can see what are the containers actually now in my task. So the Amazon Linux is actually my application container. And then now you can see under my containers section, there's another sidecar container is auto-injected for you, because we don't actually need to change anything task definition, and we just run new task, we automatically inject this new guard duty container for you. And this guard duty container is a non-essential container, which means if there's any problems, if the container is failed to start due to permission issue or network issue, or if the container exit unexpectedly due to some errors, your task won't be stopped. So all your application containers will still continue keep the current status. And also, if you see the configuration on the page, you can see that we also enforced a maximum memory limit on the guard duty container, so that we can make sure that your guard duty container won't consume unbounded memory. All these actions are trying to make sure that with this feature integration, the performance and the availability of your application's workloads won't be impacted. Now my guard duty container is running. You may start to wonder, so since I have additional container running in my task, what are the resources consumed by this new container? Do I have to be concerned about? And what actually the new task size I need to change from my Fargate task? Now we can actually take a one to actually answer all these questions, collect all these data, we can use the container insights feature we just enabled on my cluster. So to see the container insights metrics and logs that collected, we can come to the CloudWatch dashboard. And if you scroll down on the left side, you can see at the bottom there's container insights option. If you select it, it actually redirects to a page. You can see all the metrics logs for the resources that you have container insights enabled. And I can select the cluster that I have my task launched. And on the resources, you can see there's a different level of resources. I can see the metrics logs on my aggregate on my class level, and also aggregate by the task definition. So the task guard I'll choose the task definition I just launched. And then now you can see all the resource metrics related to the CPU utilization, memory utilization, also network and disk. So when you're testing, you can monitor the metrics here so you can understand what are my new task resource utilization look like. And then you can actually adjust task size based on the metrics. Also, at the moment, for the metrics, we only provide task level, the class level, service level, and task level. So you may also want to dive into what's actually the specific number, the resource number consumed by the guard duty container. And then to achieve this, we actually offer a performance log, which actually can help you to dive into more details on the container level resource usage. So if you choose the guard duty container, and then there's action button you can select, and then you can choose to show view performance log. It will redirect to your page, which will help you to collect all the queries, all the logs that relate to this container. And the query you can see is already pre-populated. So if you run the query, they will collect all the performance logs for you. And if you see an example log, you can see there's container name, which is our guard duty container. And on this log, you can see it tells you the CPU utilized, memory utilized, and all the including network and disk. So I highly recommend that when you test your cluster, your workloads, do some perform some load testing, so you can actually observe the resource utilization after this feature integration. So you understand that what actually the new task size should look like, so you can protect your production workload. Now we have the guard duty container running in your Fargate task. The guard duty container will start monitoring your container runtime and then collect all the telemetry sent to the guard duty service. And if there's any threat detected, the guard duty will generate a security finding on your guard duty, a guard duty dashboard, and which will also pinpoint the container task information. So if you come to the guard duty dashboard, and we can select the findings, and you can see there's security findings generated here. And to see an example, if you scroll down, you can see there's clustered information which tells it's dev cluster. And then it also shows me the task details and container details. This is to help you provide enough information so that you can quickly pinpoint that which containers actually generated threats so that you can take actions accordingly. So now, the first demo, we actually learned how do I enable this feature on Fargate. And for the next demo, I will be also introducing how do I enable this feature on ECS EC2 cases. So there's two more new steps, menu steps, you actually need to perform when you enable this feature on ECS EC2. The first one is the VPC endpoint creation. For the Fargate, when you actually enable this workload of Fargate, the VPC endpoint is automatically created for you. And so that you can see there's already guard duty VPC endpoint on your PC console. However, when you actually enable this feature on ECS EC2, this will need to be manually created. Once you have the VPC endpoint created, we can now need to install the guard duty agent on my ECS EC2 instances. So there's two ways of actually doing it. If your instance is managed by AWS Systems Manager, which is also known as SSM, you can there's a predefined SSM document which you can directly take advantage of. So to have your EC2 instance managed by SSM, there's some prerequisites you have to fulfill, such as you want to install the SSM agent on your EC2 instances, or you also have to update your instance profile permission for them in order to talk to the SSM service. So when you have your instance managed by SSM, you can run this predefined document, which actually packages all the commands to install and uninstall the guard duty agent on your instances. So if you choose this predefined document, which offered by guard duty, and then you will be able to see in your own AWS account as well, and then you can actually run the command. So I already have the page pre-opened here, and when you try to run the command, the only parameter you need to fulfill is to put the package name, which is the guard duty runtime monitor SSM plugin. So, and then you can select which instances you want to install the guard duty agent. And I can choose one of the ones that the ECS instance already pre-launched. And once I select the instances, I can scroll down and click the run button. And now you can see the status is already in progress. Once the status changed to successful, which means your guard duty agent already installed on your instances. So I have one instance already pre-launched and also pre-installed the guard duty agent using this assessment document. So once it's installed on your guard duty agent, you will be able to see the instance showing up on your guard duty dashboard as well. So if you come to your guard duty coverage dashboard under runtime coverage, If you select ECS clusters runtime coverage, you can see the container instances covered under my cluster. And also, if you select the EC2 instance runtime coverage, you can also see the instance showing up on this dashboard. And when the coverage status is healthy, which means the guard duty container is actively running on the instances. So this is for when your instance is managed by SSM. There's another, so when your instance is actually not managed by SSM and you also do not want to install the performance all the actions to enable it, there's another manual way to help you to install the guard duty agent as well. So the guard duty agent RPM is stored in the S3 bucket. So you can run the AWS command to help you to pull down the guard duty agent and the relative signature and the public key from the S3 bucket. So I'll show a case what actually the command you will need to run here. So if you see the script that I already created for install the guard duty agent, the first section is downloading the guard duty agent RPM signature and public key from S3 bucket. And the second section will be verify your signature. We highly recommend that after you download the RPM, verify the signature, make sure the RPM is not tampered. And then you can run the command to install the RPM, and at the end, you can check the status of the guard duty. Now I can run this script, and you can see it's installing my guard duty agent. And on the screen, you can see the status is active, which means it's successfully running. So to automate this script, you can actually package all this script, become part of your user data. So when you launch instances by autoscaling group or capacity provider, it will automatically run for you. So when your instance is launched, you already have guard duty agent installed on your instances. And similarly, if you start to run your ECS task on this ECS EC2 instances, the guard duty agent will also generate findings on behalf of you. So to show an example that I already created, which is the finding on the ECS EC2 instances, the difference here is on the bottom section, you can see that it actually also provides you instance details, which pinpoints which instance and all the other information that you may want to know about your instance. So that's all for today's demo. I'll hand over to Spiros.
Thanks, Yumeng. So in summary, if there is one takeaway to take away from today's presentation, is that with the introduction of this feature on ECS and Fargate, as well as the existing support for guard time, runtime monitoring for EKS, and the preview of doing this for EC2, you have the ability to turn on threat detection for runtime threats across the whole gamut of AWS compute. And if you're interested in trying this feature, Guard Duty also offers a 30-day free trial for you to try out. If you're still interested in ECS and Fargate, there's still time, if you don't have any plans, to go to some other breakout and builder session. And if you haven't had the chance to visit our modern apps on the floor, it's at the very back of the far right. So stop by the serverless espresso to see how Lambda can make you coffee. And with that, we'd like to thank you for joining our session today. Please remember to give us some feedback in the mobile app. There's still some time. Yumeng and I will be here to answer any questions you may have. Thank you.